Hydrates.com.
So group 15 is also called as a nitrogen family, and because of its inert nature, the presence of presence of these gases will feel the deficiency of oxygen. These gases are inert in nature. That's why they are called as a Pnicogens. What they are called as? Pnicogens. Pnicogens means insufficiency of oxygen. The presence of these gases will feel the insufficiency of oxygen. Okay, so group 15 are nitrogen family are Pnicogens. All are same, and the elements belonging to this family are nitrogen, phosphorus, arsenic, antimony, and bismuth. These are the some elements of the 15th group. Okay, now their atomic number. Every group contains some general electronic configuration. See, there is a trick. The trick is that 15 means 5. That 5 shows that there will be 5 electrons in the valency shell. Okay, so this is inert gas. Ig means what it is? Ig stands for inert gas. Other than the inert gas, there will be 5 electrons, Ns2, Np3. This is the general group configuration. Every group contains some general electronic configuration. What is that configuration? Inert gas, then Ns2, Np3. Okay, so if I keep on changing the gas here and keep on changing the N value, I can write the electronic configuration of all elements. Like if I substitute N equal to 2, here N value starts from 2. Okay, so 2, 3, 4, 5, 6. So up to where it will go? Up to 6. 2, 3, 4, 5, 6. So the first inert gas will be helium, and it can be written as 2s2, 2p3. Then same way helium, after the helium, then it will be neon. Then it will be 3s2, 3p3. Helium, neon, then it will be argon, 4s2, 4p3. Then it will be krypton. Okay, 5s2, 5p3. Helium, neon, argon, krypton, xenon. Okay, xenon, and it will be 6s2, 6p3. This type of configuration is called as a condensed electronic configuration. What it is called as? Condensed electronic configuration. Then what it is called as? General group configuration. Here inert gas changes and N value changes. N value starts from 2 and reaches up to the 6. Now here if you see this gap between 7 and 5, 7 and 15, what is the gap here? 8. And here also it will be 18. Okay, 18, then it will be 32. So these numbers are used to find out the next atomic number. Okay, what are the magic numbers? These are numbers are called as magic number. What are the magic numbers? 7 plus 8, you will get 15. 15 plus 18, you will get 33. 33 plus 18, you will get 51. 51 plus 32, you will get 33, 83. So this series you should remember. It is applicable for all group. Okay, what is that series? 8, 18, 18, and 32. This number if you remember, and if you start only with first atomic number, then you can find the atomic number of all elements. 8, 18, 18, 32. You will get the atomic number of all element. Okay, so let us start. This is a trick to remember the atomic number. Understood? And trick to remember electronic configuration, is it understood? You just change the inert gas, then change the number, you will get the electronic configuration. Once you know the electronic configuration, once you know the atomic number, then the things will get easily. Okay, nowadays in the present examination there is a integer type question. Okay, So as per the current pattern, you should be able to prepare yourself. NCRT is same. NCRT is same, but the way of studying to NCRT should change as per the current examination pattern. Okay. So this is a non-metal. This is a non-metal. Okay. This is a metalloid. What it is? This is a metalloid. And this is also metalloid. Okay. And only the metal is bismuth. Okay. So number of metals are how many? 1. Number of metalloids are how many? 2. Number of non-metals are how many? 2. Okay. Number of non-metals also 2. Number of metalloids also 2. And number of metal only 1. Okay. Only 1 metal, 2 metalloids and non-metal. Okay. So question may be why there is a change in this property. Okay. Reason, there may be logic, there may be reason they may ask why there is a change, because down the group ionization energy what happens? Decreases. Okay. Once ionization energy decreases, hence metallic nature what happens to metallic nature? Metallic nature increases. Okay. And non-metallic nature nature decreases. Okay. So this is the reason and this is the series. Everywhere there may be order and there may be reason. Both way you should prepare. And for integer type, how you should remember? Number of non-metals 2, number of metalloids 2, number of metals only 1. Okay. And metallic property down the group increases. That's why see more non-metallic, less non-metallic, metalloid, then it will be complete metal, typical metal. It is called as a typical metal. Okay. So this is what called as typical metal. Okay. It is called as a typical metal. Now let us see about the next topic. Up to here, I think everybody is clear. If any question arises from the electronic configuration, any question arises from the atomic number, any question arises from the metallic nature and reason, number of all way, you should be prepared. Okay. So question will be why nitrogen is gas. Okay. But phosphorus is solid. Okay, this question will be why nitrogen is a gas but phosphorus is a solid. Okay. Otherwise, same question may be asked as why nitrogen is diatomic. Why nitrogen is diatomic. Okay. Diatomic in the sense nitrogen is found as an N2. Okay. But phosphorus is tetraatomic. Phosphorus is what? Tetraatomic. Okay. That means phosphorus you will find it as a P4. This question is different. This question and this question appear to be different, but both of them have the same answer. Why nitrogen is a gas but phosphorus is a solid? Why nitrogen is diatomic and phosphorus is a tetraatomic? Okay. So how to answer them? This type of question will be the reasoning question. Which of the following is most appropriate for diatomic nature of nitrogen? Or the question will be which of the following is correct explanation of phosphorus is a solid? So in that condition you should be able to identify. Okay. So I am explaining the reason. Listen carefully. Okay. Nitrogen have to form 3 bonds. How many bonds? 3 bonds. Phosphorus also should form 3 bonds. But in nitrogen, due to small atomic size, the first formed sigma bond. Whenever there is a bond formation, the first bond formation will be of sigma bond. Okay. So the bond is very small enough that the other orbital can undergo sideways overlap. Can undergo which overlap? Sideways overlap. Okay. So this is vertical plane. and there will be a horizontal plane like this. Okay, see, this is vertical plane, this is horizontal plane. So this plane is vertical plane, and this plane I am telling you about the horizontal. So there will be two types of pi bond. There will be how many types of pi bond? Two types of pi bond. This sigma bond will be axial in the axis, and in the axis vertical plane there will be this pi bond. Okay, and perpendicular to this there will be another pi bond, this which I am going to draw it. Okay, so this is one lobe is back side and one lobe is front side. Okay, so this and this, there will be pi bond. Is it understood? So this type of facility is available only in case of the nitrogen. Why? Because of the small atomic size, nitrogen sigma bond is small enough. Okay, now but for phosphorus, phosphorus is big atom. So then what happens? The atom bond length is more. Bond length is what? More. So is it possible for sideways overlap for them? By between them, sideways overlap is not possible. But this phosphorus got how many orbital? 3 orbital. One orbital participated in bond formation. Two more orbitals are there. Okay. How many orbitals are there? Two more orbitals are there. They also need to be formed. They also need to form bond. Then there is a no problem with the sigma bond. Sigma bond can be formed from larger distance also, because sigma bond forms due to head-on overlap, whereas pi bond forms due to sideways overlap. Sideways overlap requires small distance, head-on overlap requires large distance. Okay, so that means if each phosphorus have to form how many bonds? 3 bonds. Okay, so like this is a phosphorus, so it will form bond with how many phosphorus? 3 phosphorus, 3 sigma bond. Okay, but the problem is that it could complete all the 3 bonds. This also should complete bonds. Then this will form bond like this. So its 3 bonds are also over. But what about this? This also need to form one more bond. This also need to form one more bond. So there will be one more pi bond like this. Okay. So likewise, there will be each phosphorus connected to 3. Then total number of phosphorus are how many? 4. Okay, so that's why phosphorus is tetraatomic. What it is? Tetraatomic. It is a pyramidal in shape. Okay, this will be pyramid like this. What it will be? It is going to be pyramid like this. One phosphorus, second phosphorus, third phosphorus, fourth phosphorus. Okay, this is the only way it can complete its trivalency. But nitrogen also completing the trivalency, but it in the other way. Here the trivalence is completed by 1 sigma bond, 2 pi bond, but here trivalence is completed by 3 sigma bonds. Okay, so that's why nitrogen is diatomic and phosphorus is tetraatomic. Okay, so nitrogen diatomic is very small, phosphorus tetraatomic is very big, because how many phosphorus are there? 4 phosphorus are there. So can it evaporate like this? It cannot evaporate, and it can easily evaporate due to small size. That's why it is a gas and it is a solid. Is it understood? Why nitrogen is a gas? Why nitrogen is a gas but phosphorus is a solid? Once again I am explaining in a short way. Okay, and English terminology which you will find in the option. Okay, with nitrogen due to small atomic size, it can form sigma bond as well as pi bond. Pi bond is possible only when sigma bond is small enough. So all the 3 bonds can be completed by nitrogen with only other nitrogen. Okay, nitrogen does not require any other person, only second nitrogen is sufficient. Okay, with the same nitrogen it can form all the 3 bonds. Okay, why? Because of the small atomic size. So all the 3 bonds completed, so it will not react with any other one. But phosphorus cannot do that. That's why each phosphorus connected to 3 phosphorus. Again each phosphorus connected to 3 phosphorus. Each phosphorus connected to 3 phosphorus. Like that, minimum how many are required? 4 phosphorus are required. Is it understood? I think now it is clear to you. Question may be different. Question may be like why nitrogen is gas or why nitrogen is diatomic. All the way you should write the same answer. Is it understood? Okay. Next question will be ionization energy. Okay, down the group, ionization energy decreases. Ionization energy, what happens? Decreases. Why decreases? Due to increase in atomic size. But there is an exception. Okay, like carbon, nitrogen. When you move from left to right, when you move from left to right, atomic size decreases. Okay, what will decrease? Atomic size decreases. Therefore, ionization energy should increase. Okay, and nitrogen, oxygen. Okay, so what should be the format here? Carbon greater less than nitrogen less than oxygen. This should be actual format, actual order. Okay, so carbon, nitrogen, oxygen. The atomic size decreases, so ionization energy should increase. But there is a change. This oxygen will not be here. It will be below the nitrogen. Okay. Question will be why ionization energy of oxygen. Question will be what? Why ionization energy? The otherwise IE1 of oxygen is less than nitrogen. Okay, why ionization energy 1 of the oxygen is less than nitrogen? Then you should explain in terms of the electronic configuration. In nitrogen it is 2s2 2p3. Okay, this 2p3 is a stable 2p3 is a stable half-filled configurations. 2s to 2p3 is a stable half-filled configuration. Okay, whereas in oxygen it is 2s2. In oxygen it is 2s2 2p4. Okay, so it is unstable. It is unstable normal configuration. Okay, normal configuration. See, think about its situation. It is already stable. If it loses electron, it will become unstable, and it is unstable. If it loses electron, it will become stable. So it becomes stable by losing, it become unstable by losing. So who will lose easily? This will lose easily because it is benefited to it. Understood? That's why its ionization energy is less than the nitrogen. Okay, as per the atomic size, who is supposed to be? As per the atomic size, the ionization energy of oxygen should be more, but because of the electronic configuration, there will be change in, because of the electronic configuration, change in the order. Okay, nitrogen exists in not only nitrogen, it happens with the all the 15th group elements. Okay, so that is the reason ionization energy. Now there is a question or anticipated question. Okay, which of the 15th group shows the highest electronegativity? Okay, what will be the answer? Nitrogen. How much its electronegativity on the negativity scale is 3. Okay, and how many elements show the same amount of electronegativity? What will be the answer? 2. What are those? Sb and Bi. Okay, nitrogen, phosphorus, arsenic, antimony, bismuth. Down the group there should be decrease. There is a decrease also. Okay, 3, 2.1, 2 and 1.9. See, decrease is very large here. Here there is a difference of how much? 0.9. But here decrease only 1. Here decrease is only 1. Here decrease is 0. Okay, sorry, 0.1, 0.1 and 0. Understood? Down the group electronegativity decreases, but also quantity of decrease also decreases. Understood? It is decreased by 0.9, whereas it is decreased by 0.1 only. It is decreased by 0.9 and it is decreased by 0. Okay, now question will be why. Okay, as most of the students are getting this doubt. Okay, here you should write the electronic because the addition electron enters into anti-penultimate shell, and anti-penultimate shell or penultimate shell. Okay, what is penultimate shell, anti-penultimate shell? If n is the valency shell, then n minus 1 is called as a penultimate shell, n minus 2 is called as a anti-penultimate shell. Okay, suppose sixth energy level is the valency shell, then fifth energy level is going to be penultimate shell, and fourth energy level is going to be anti-penultimate shell. Likewise, there will be electron when enters into the valency shell, effect will be more on the chemical properties, but here electrons are not entering into valency shell here also. Okay, only here electron enters into the valency shell. After that, the electrons start entering to the inner shells. What are the inner shell? Penultimate shell and anti-penultimate shell. Is it understood? So that is the reason oxidation number and electronegativity. These two, how to understand, and any doubt about this? Ionization energy down the group decreases. That is not important. What is important? This is important. And in electronegativity, what are the important things? Which is more electronegative and what is its value? Nitrogen is more electronegative and it is third most electronegative. Okay, in the universe, highest electronegative element is what? Fluorine. Okay, so phone, you remember as a phone, FON. Okay, fluorine, oxygen, nitrogen. Phone, fluorine, oxygen, nitrogen. Fluorine is highest, second highest is oxygen, third highest is nitrogen. Like that, these are the some important questions in the introduction lecture of the 14th group, sorry, 15th group, are nitrogen family or Pnicogens. Okay, we will meet in the very next lecture. I hope all of you understood now. Okay, I am drawing the tabular form given in the NCERT. From that NCERT, people says that the question is not from NCERT. Question will be from the NCERT, but question will not be directly from the NCERT. Okay, and how to memorize? The main problem people are feeling is how to remember the things and how to study in the examination point of view. Okay, so these are the some hydrides of 15th group: nitrogen, phosphorus, arsenic, antimony. Okay, and deliberately I have not written bismuth. Why? Because bismuth being the hydride of the metal, bismuth being the hydride of the metal. Okay, so metal hydrides are not much important. Out of the total 5 elements, first two elements are non-metal and rest two elements are metalloids. In the metalloids also you will find some metallic, non-metallic character. That's why they also play a vital role. Okay, why bismuth hydride is not much important? Because it is the only metal hydride. Only metal hydride. In the metal hydride of the metals, the hydrogen exhibits -1 oxidation state. What oxidation state? -1 oxidation state. So in the NCERT melting points, there is a tabular form is given. Like NH3 is 195.2 they have given, and it is 139.5 given, and 156.7 given, and it is 185 is given. These are the melting points given. Okay, next boiling points are given. Boiling points are given as 238, 238.5, 188, 185.5, 210.6, 254.6. Okay, these are I am writing as per the NCERT. Okay, but questions will not be these values. The main problem is that people are not able to understand how to study. Okay, they are keep on mugging up, and in the examination they are forgetting the values. Okay, so how to study and how to memorize this I am going to tell you. 107.8 and it is 93.6, 91.8, 91.3. Then there is a column, enthalpy of formation. Enthalpy of formation. Okay, enthalpy of formation is -46.1 plus 13.4 plus 66.4 plus 145.1. Okay, and dissociation bond enthalpy. Okay, that is 389 and 322, 297, 255. Okay, so these are the values given to you, given in the NCRT. These are the values given in the NCRT. Now, how to memorize these values? In last 5 to 10 years, they never asked what is the melting point of PS3, what is the melting point of SBH3. They always asked either lowest or highest, or what they asked, second lowest, second highest, like that they asked. Otherwise, increasing order of melting point, decreasing order of melting point, like that they have asked. So to ease, as per the question pattern, you don't by heart these values, but you have to arrange them as per the order. Okay, so in normally in any hydrides, down the group melting point should increase. Melting point should what happen? It should increase. Okay, so it should be like this: NH3, PH3, PH3, ASH3, and SBH3. Okay, this is the normal order. Okay, but people will say the chemistry is full of exception, but it is not like that. Every exception got a reason behind it. If you know the reason, then it will not be exception, and it will not be difficult for you to memorize. Okay, now the actual order is to be like this. Okay, so how you will write the notes? You will write the notes from these values, NCRT values. See, 139, 156, 185. It is okay. Now this 195 is to be placed where? Like this. You make an arrow and write like this. When you will write here, boiling point. So just one arrow only you should remember. For boiling point, I have to jump. For boiling point, I have to jump the ammonia from here to here. If you remember that single point, all questions related to the, let it be increasing order, let it be decreasing order, let it be highest, let it be lowest, let it be second highest, let it be second lowest, all things can be simply with one point. What you should remember, boiling point, ammonia jumps to the highest value from the lowest. It takes a maximum jump. It takes jump from the lowest to highest. That point is sufficient. I can give you in the guarantee will be able to answer all questions of the, sorry, this is melting point. Okay, so this jump is from the melting point. These values are written according to the melting point. All the questions related to the melting point which came as of now, which will come in the future exam also, you will be able to memorize. Okay, now let us see about the boiling point. Okay, this order will remain same. This is a normal order as per the normal rules. Now the question may be why this jump took place. Question answer will be intermolecular hydrogen bonding. What will be the answer? Intermolecular hydrogen bonding. Reasoning question, I think you understood. Due to intermolecular hydrogen bonding, ammonia jumps from here to here. Ammonia will jump from here to here. Okay, because of which the strong force of attraction. Here PH3, it is van der Waals force, ASH3, strong van der Waals force, SBH3, strong, more stronger van der Waals force. Van der Waals force depends upon the size or mass. Size of the central atom is increasing, therefore van der Waals forces increases. But other than this ammonia, apart from the van der Waals force, it exceptionally have stronger hydrogen bonds. Hence, it jump from here to here. This is the melting point. Okay. Now this I am erasing this. Okay. Next, coming to the boiling point. What type of jump it should take place? See, 238 to 185 210. See, it is in between these two. So boiling point, what you will write? You will write like this. Okay. Now the question will be why there is a large jump in melting point, small jump in the boiling point. Anybody knows the reason? If anybody knows the reason, please send it to me. So this is how you have to remember the order. In boiling point, you will make a jump from this place to this place. In melting point, you will make a jump from this place to highest possible place. Is it understood? So this is the orders question and how you are getting it, and along with the reason. Is it understood? Now let us start with the angle point of view. What is the next question? The next question from the NCERT table is based upon the angle. NCERT table is based upon the angle. See here, 107.8, 93.107.8, 93.6, 91.8 and 91.3. Okay, so here it is keep on decreasing. Now question is why it is decreasing. What is the question? Why bond angle is decreasing? Okay, now coming to the angle part, how to remember and what is the reason behind it, I am telling you. See, you will find 1097 to 93.6, then to the 91.8, then to the 91.3. Okay, if the question is why the bond angle after phosphorus and further phosphorus nearly 90, then your answer will be pure orbitals are involved. Okay, what your answer? Pure orbitals are involved in bond formation. But question is about the same question is asked why there is a decrease. Then you should explain in terms of the electronegativity. Now let us imagine about the NH3, nitrogen, phosphorus, arsenic, antimony. Okay, all of them are attached with the hydrogen. All of them are attached with the hydrogen. All of them are attached with hydrogen. But the charge on the hydrogen is different. What is different? The charge on the hydrogen is different. Here nitrogen being more electronegative. So this is more electronegative among the all central element. So once it is more electronegative, the element corresponding will have correspondingly more positive charge. Will have more correspondingly positive charge. This positive charge will be more, positive charge will be more, positive charge will be more. Okay, and in this case partial negative charge is less. So partial negative is less, therefore partial positive will be less. So partial positive is less, repulsion will be minimum and repulsion will be maximum. Okay, so maximum repulsion, then there will be increase in bond angle. When repulsion is maximum, there will be what? Increase in bond angle. See, you can see value also 107. Here repulsion is less, so bond angle will be minimum. So you can see bond angle is 91.3. Is it understood? Bond angle and its reason and its order. Okay. Okay, next is enthalpy of formation. What is the next? Enthalpy of formation. It is minus 46, it is plus 13, it is plus 66.4, and it is plus 145.1. So from this what you can understand? Thermal stability. Question will be on the basis of this thermal stability. Okay. So if the order of thermal stability, thermal stability. Thermal stability is inversely proportional to enthalpy of formation. Is inversely proportional to, not modulus. Along with the sign you have to take it. Thermal stability is inversely proportional to enthalpy of formation. See here, lowest enthalpy of formation minus. This is less positive, more positive, more positive. So as the positive value increases, what happens? Thermal stability decreases. So highest thermal stability is of the delta FH. Okay. Next, coming to the enthalpy of dissociation. What is the next one? Enthalpy of dissociation. What is the enthalpy of dissociation about here? It is the bond length. Okay. And it is asked in other way, reducing power. Okay. Suppose nitrogen and hydrogen, bond length is small. Okay. Phosphorus and hydrogen, bond length is bigger. Arsenic further bigger. Okay. Antimony further bigger. Understood? So bond length increases. What increases? Bond length increases. So bond energy decreases. Bond energy, what happens? Decreases. See, bond energy 389, 322, 297, 255. What is the reason for thermal stability and enthalpy of dissociation? Is it understood? Any doubt about this? So I will give a summary of the table in which the examination questions you can answer. Okay. First one is NH3, nitrogen, phosphorus, arsenic, antimony. Okay. Now first melting point. Melting point, what I told you to write, it should be here. Okay. So from here to here it increases. Lowest is pH3, second lowest ASH3, SBH3, then highest is NH3 in melting point. Okay. Then in boiling point, it will jump, and in between these two, it will jump where? In between these two. Okay. In this direction, it will increase. Okay. So lowest is here also pH3. Second lowest will be ASH3. Third lowest will be NH3, then followed by SBH3. Okay, melting point and boiling point, is it understood? After the melting and boiling point, bond angle. Bond angle down the group, what happens? Decreases due to decrease in electronegativity of central element. Due to decrease in electronegativity of central element. Okay. Then thermal stability. Then what? Thermal stability. Okay. Thermal stability down the group, what happens? Decreases. How you can come to know? Only hydride with negative enthalpy of formation is ammonia. Only hydride with negative enthalpy of formation is ammonia. Rest all will have the positive enthalpy of formation. Positive of enthalpy of formation is a sign of the instability. Okay. Then bond energy. Bond energy down the group decreases. Okay. So because of the bond energy, what are the consequences? Bond energy decreases. Therefore, reducing power increases. What will increase? Reducing power increases. Okay. Basic nature decreases. Basic nature decreases. These are all because of the bond enthalpy. Is it understood? Okay. This all about the hydrides of the 15th group. This way you have to, without going behind the beyond the NCRT, within the NCRT exam oriented point you should study. Is it understood? Okay, bye bye, see you.